In this Math 30-3 Properties of Geometric Figures video, we will focus on naming or classifying polygons, including triangles and quadrilaterals, and solving for unknown angles. First, a little background knowledge you'll need. Hatch marks can be used to show which sides of a polygon are equal, or by using double or triple hatch marks, which sides are different side lengths. Angle arcs are similar. They can show two angles are equal, or they can show which are not equal. When it comes to arrows for parallel lines, we use arrows that look like this to indicate that two lines are parallel to each other. Parallel means if we were to extend these lines forever and ever, they would never cross. They would always be the same distance apart from each other. There are some special properties related to parallel lines that we'll use later when solving for unknown angles. We've got lots of names for geometric figures. Here's just a few, or 22. There's triangles that can be acute, equilateral, isosceles, obtuse, right, scalene. There's the quadrilaterals: parallelogram, rectangle, square, rhombus, trapezoid. There's isosceles trapezoid and right trapezoid. Can't forget kite. And this isn't even all the other polygons. We've only gone up to 12-sided: pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, dodecagon. We can organize them to make a bit more sense though. Basically, all the geometric figures we'll discuss in Math 30-3 are polygons. But within polygons, we have a few different classifications. Let's focus on triangles first. These polygons are identified by having three sides. From what we already know, the angles in a triangle add up to 180 degrees. Triangles can be classified by their angles: acute, right, or obtuse. Triangles may also be classified by their side length: equilateral, isosceles, and scalene. When we want to classify triangles by their angles, acute triangles' angles are all smaller than 90 degrees.
A right triangle has a right angle, meaning an angle equal to 90 degrees.
An obtuse triangle has an angle larger than 90 degrees. When it comes to classifying triangles by their side lengths, equilateral triangles' side lengths are all equal. An isosceles triangle has 2 out of 3 side lengths equal, while scalene triangles' side lengths are all different. Notice the hatch marks show you which sides are equal and which sides are different. Consequently, since equilateral triangles' sides are all equal, so are their angles. Since we know that a triangle's angles add to 180 degrees, that means an equilateral triangle has angles equal to 60 degrees. Angles less than 90 degrees are considered acute, hence why all equilateral triangles are acute. Isosceles and scalene triangles can have all acute angles, or they can be obtuse, have an angle larger than 90 degrees.
Right triangles can have 2 equal side lengths and be isosceles, or have 3 different side lengths and be scalene. Quadrilaterals, our next polygons, are identified by having 4 sides. The angles in a quadrilateral add up to 360 degrees. Quadrilaterals can be classified by how many pairs of parallel sides they have. Parallelograms have 2 pairs of parallel sides, trapezoids have 1 pair of parallel sides, and kites have none. A kite is simply a 4-sided shape that has 2 pairs of adjacent side lengths that are identical. All parallelograms have 2 pairs of equal side lengths, so we include hatch marks. First, a rectangle is a type of parallelogram since both pairs of sides are parallel to each other. It's special or different from other parallelograms because all 4 angles are 90 degrees. A square is even more special since in addition to having all 90-degree angles, all 4 sides are equal lengths. A rhombus has 4 equal side lengths, hence why a square is a type of rhombus. Being parallel does not automatically mean the sides are equal like we see in trapezoids. While all trapezoids have one pair of parallel sides, they can have all different side lengths, or they can be isosceles, meaning the same thing it did for triangles. Two side lengths are equal, and because of this, two angles are equal as well. A right trapezoid has two right angles. We can also identify quadrilaterals by whether their diagonals are equal or not. In geometry, diagonals look like X's through the shape. Rectangles, squares, and isosceles trapezoids all have equal diagonals. We can prove this with the knowledge of the congruent triangles that make up the shapes, but we'll leave that exploration up to you. The other quadrilaterals do not have equal diagonals. Polygons can be regular or irregular. We give the regular definition to polygons whose sides are all equal and whose angles are all equal. Irregular just means that not all sides and not all angles in the polygon are equal to each other. These are both pentagons. The one on the left is a regular pentagon. The one on the right is an irregular pentagon. Here are some helpful tips you can use for solving for unknown angles in polygons. For triangles, if you've got one unknown angle, you can subtract from 180. If it's isosceles, we know two of the angles are equal. Equilateral triangles' angles must be 60 degrees because they have to add up to 180 and all be equal to each other. For quadrilaterals, if you've got one unknown angle, you can subtract from 360. If it's isosceles, we know two of the angles are equal. Quadrilaterals with parallel sides also have a unique property when it comes to their angles. When a quadrilateral has a pair of parallel sides, the angles made by a connecting side add to 180 degrees. So if we're missing an angle in a parallelogram or trapezoid, and we've got the other angle with its connecting side, we can subtract from 180 to determine the unknown angle. For other polygons that have 5 sides or more, there's a quick formula you can use to determine what all the angles in the polygon add up to. Take the number of sides, subtract 2, and multiply by 180. We can also solve for each angle in a regular polygon by dividing the sum of the number of angles by the number of sides. For example, a pentagon has 5 sides. 5 subtract 2 is 3. 3 multiplied by 180 equals 540 degrees. So if you've got one unknown angle in a pentagon, you can subtract from 540. A regular polygon is even more special since we know all the angles are equal to each other. In a regular pentagon, we'd take 540, the sum we calculated already, and divide by 5, the number of sides, to calculate that each angle is equal to 108 degrees.